Welcome to the 7th video on the free and open source Godot game engine platformer series. In this video, we are creating new elements for the level design that will allow us to expand the level with new mechanics. We are referring to moving platforms and ladders. Also, as the project is growing, we are taking a look at structuring it correctly, mainly from the point of view of the scripts that we have been creating and keeping on the root folder. Let's dive into Godot. Let's set up our moving platform. The first thing that we have to do is to create a new 2D scene from the scene menu and new scene option. In the panel to create the root node, select the 2D scene option. Rename it to moving platform. Add a new node by either right-clicking on the moving platform or by clicking on the add sign on the hierarchy tab. In the search bar, type kinematic, and then select the kinematic body 2D. Select again the moving platform root node and add a new node. In the search box type in tween, and then select the tween node from the list. Let's configure it. In the inspector panel, from the playback speed drop-down box, choose the physics option. Set the repeat field to on by clicking on the checkbox. Select the kinematic body 2D and add a new node of type collision shape. And let's quickly configure in the inspector. Set the shape to rectangle shape 2D. Let's select again the kinematic body 2D and add a new shape of type sprite to render the platform sprite that we will be using. Next, from the project folder, under resources open the platform subfolder and drag the platform sprite onto the texture field of the sprite just created. We can see that the collision shape is behind the sprite, so let's invert the order on the project hierarchy to make easier to see the collision shape and adjust it to the size of the platform. Let's select again the kinematic body 2D, and in the inspector pane, let's set the collision mask to be interacting only with the player, by clicking on 3 dots on the right, and then selecting the right options for the dialog menu. Now let's add 2 nodes that will define the start and end point for our platform, as to place it visually on the level and not having by defining it with coordinates. Rename to the name that will suit you the best. In our case, we will use starting and end point. Let's move the endpoint somewhere out to the right. Time to code the basic functionality of a moving platform. So, select the root node and click on the Add Script button to a script to the node. In the new dialog window, let's keep the suggested name based on the name of the node. Click the button Create to finish the process and add the script to the node. The first thing that we will do is to add a new line before the extends instruction and add the tool keyword. This will allow our script to be run in real time in the editor, and that will allow us to preview more or less in real time the outcomes of our changes in the code. Use it with precaution, as it can seriously put at risk your work environment and stability and performance. Next, let's add some parameters to be used from the inspector, using the keyword export in front of the definition. We will start by creating two variables to hold the reference to the starting and end points and try to access their positions. Godot is not like other game engines, where you can access all the relevant properties of the objects that you can receive into a script. Godot doesn't allow that directly. So to achieve this effect, we have to use a workaround via node paths, which are the paths needed to browse the project hierarchy and get any node. Once we have those references to the node paths, on the on-ready state, let's save into two variables the actual nodes using the getNode method with the node paths. Next, let's cache the reference to the moving platform node by saving the reference into a local variable. But before doing, let's quickly change the name of the node from the kinematic body 2D to platform. Once done, let's save into the variable myPlatform the reference to the platform node. Let's repeat the process to the tween node and save the reference into the variable myTween. This is a simple step to make, but that in the long run and with larger games, can save a lot of performance problems. Let's define, with the export prefix, an idle wait time for the platform, that will represent how long we want the platform to stay at the peak of its movement. So, for instance, if we set the value to 1, then the platform will wait for 1 second before starting to move in the opposite direction. And finally, the platform speed that we want to have for the platform when on the move. Let's go now to the ready function. And let's call the function that will start the platform movement, in our case, tween platform movement. Next, let's define it. Within the function, the first thing that we will do is to calculate how long it will take for the platform to go from the starting to the endpoints. Then we can calculate the duration by dividing the distance of the movement, which is represented by the length of the vector 2 where we saved the endpoint, divided by the speed at which the platform will be moving. This value will be used to calculate the movements to be defined by the tween node. So, let's start tweening the movement of the platform by calling the method interpolate property from the myTween class. It receives as the first parameter the reference to the node that needs to move, in which case it is our platform kinematic, then an indication of the parameters that we want to interpolate, which in our case will be the position. We need then to pass the starting and end position, that has been saved in our local variables movePLT_from and movePLT_to. Followed by the duration we want the movement to take. Next, we need to tell the tween object what type of tween we want to perform that will be a linear transformation. Followed by how we want the transition between tweens to happen, for our case, will be set to ease in out. Finally, how much time do we want to stay in the same place, once the platform has reached its objective? We will set it with the value of the platform waiting time. This will deal with only one half of the animation. The one that goes from the start point to the end position. So, if we want the platform to go back in the opposite direction, we need to do a new tween that will start on the ending point and conclude on the start point. For that, let's copy the current instruction and let's invert the start and end positions. We need also to change the last time calculation, as we want the platform to restart the tween after it has waited for the wait time and then came back to the start point and waited for a new waiting time, which is 1 duration plus 2 waiting times. Up to now, we have just been configuring the movement of the platform. If we were to run the game, we wouldn't see anything moving. We need to give the tween functionality the final go, by using the myTween.start method. Let's go to the platform view, and if there is no mistake you should be able to see the variables that we have exported from the script where you can set the main properties to control the platform. Let's take the opportunity to set the references to the start and end point. Let's go back to the game view, and from the project folder, select the moving platform scene and drag it onto the hierarchy pane. Zoom out and pan the game view until you can see the platform. Let's drag the platform to the beginning of the level. On the hierarchy pane, right-click on the moving platform node, and from the pop-up menu, select the option Editable Children. You will now be able to see all the children nodes on the moving platform. Let's edit the position of the end point and move it to be right below the platform. This will generate a vertical movement from the ledge of the player to the bottom of the level. We need to assign the start and end point to their slots in the script. So, let's go to the platform, select the start and end point of the script and associate them with each of the nodes created. Let's run the game. And, we have a mistake in the code. Okay. The first one is associated with the fact we have forgot that length is available associated with the vector2 position and not with the node. So, let's fix the reference. The second error is that we have misspelled the first interpolate function that doesn't start with a capital I. Let's run again the game. And the code is working. You can see that the platform starts moving down and up, although with some small glitches. But, if we jump onto it, we can see that it is already moving the player along. Let's try to move one of the points to another position in diagonal. And let's run the game. And the platforms correctly follow along the new lines. The movement is too slow. So let's speed it up to 30 in the platform speed parameter for the platform. Let's check how it looks in the game. Great! It looks and feels better. Let's improve its applicability on a game by showing the lines the displacement of the platform and a couple of colored bullets that will show the points that will limit the movement range. So, in the code, let's use a predefined function named draw that is used to draw visual elements in the editor. In the function, let's check if the function is being run in a script that has the tool mode enabled, with the engine is editor hint method. If it is the case, then we will draw a line from the start point to the end point with green color, and 8 pixels in width. Then we will draw at each for the source and destination points, 2 circles with a width of 10 and a second line that will go from the end point to the start point, with the red and blue violet colors. To see the changes, we have to shift the focus of the view from one window to another, and when going back to the original you will be able to see the new line and circles. None of the new lines is rendered while the game is being played. Now, it is time to review another of the key elements in some types of games: the ability that allows the player to move between platforms and levels, heights, in the game. They are not very difficult to implement, but they can hide some surprises that can make them difficult to implement. The first thing that we have to do is to paint some ladder on our level that we can use as a visual reference for the ladder. We could do it in different ways, but in our case, since we are using tile maps, we will use them to paint a nice ladder up and up. For that, select the tile map node where your level is defined, and then from the cells pane, select the cell that you want to paint on. Since we will be wanting to show a horizontal platform, we will put another moving platform at the end of the level. But with a horizontal movement toward the right, back and forth. If we run the game now, we can see that when on the ladder nothing happens because there isn't any logic associated with it. So let's add the capacity to start climbing the ladder. So let's create a new scene 2D. Add a new node to the scene of type area 2D and rename it to ladder trigger. Right-click on the node and click on the option Make Scene Root, and delete the node 2D as won't need it anymore. Next, add a collision shape to the ladder. And on the inspector, under the shape field select the rectangle shape. And then in the ladder trigger object set the collision mask to be on the player. Let's now add the code to operate this trigger. Click on the Add Script button, and when prompted click Create. Delete all the code except for the extend statement. Go back to the scene view and in the inspector view, under the Node tab, select the single on body entered, and click the button Connect. In the new dialog box validate that the right object and script are selected and press the button to connect. Repeat the same process for the body exit signal. And we should have the two functions predefined in our code. Before proceeding forward, let's save the ladder trigger scene. We will not yet implement any code here, as we have first to set the basis in other files. Let's go to the player script, and let's start by adding a new state that we will be calling on ladder. Next, let's define a speed at which the player will go up the ladder with a new const ladder speed that we will be set to 30. Let's add a new variable of type bool that we will be using to reflect that the player has entered the ladder trigger area, and that will serve us to move into the on ladder state. Since we will have to move up and down the ladder, let's define a couple of new variables that will hold the result of pressing the up and down key. Next, let's go to the physics process. If we are on the ladder, it doesn't make sense to apply any kind of gravity to the player, as we are the ones that will want to move it up or down. So, let's add an if statement where we will be checking if the boolean on ladder is true or false. We will apply or not the gravity to our game object. Next, let's go to the execute state, and create a new state player state on ladder. And let's set our label tag to on ladder. Let's stop the movement on X and Y. Before implementing more things, let's address the changes of state, as to check if everything is running accordingly. So, let's go to the change state, and on idle, walk and jump, let's add the code where we are testing if onLadder is true as to decide if changing to the onLadder state by setting the current state variable to player state onLadder. Let's go now to the ladder trigger script and fill the two signal functions. The first thing that we have to do, as to avoid errors, is to check if the variable onLadder exists in the body that has triggered the signal. We can do this by using the code if onLadder is in body, it is the case, then we will set it to true. Let's add to the code to set onLadder to true. Let's copy the code to the exit. But set it to false, as the body has left the trigger area. To avoid walking all the levels to test the functionality, let's drag the player to a point closer to the ladder. And let's drag the ladder trigger scene onto the game scene. Let's size it to fit the ladder correctly in terms of size. Let's run the game and let's go to the ladder. And we can see that as soon as we get on the ladder, the state of the player changes correctly, although doing nothing else than stopping. So, let's continue coding the onLadder state. Since we want the player, for now, to be able to go left and right, we will have to check on the state if any of those keys have been pressed to change the direction of movement accordingly. So, for that, let's check for each of those directions if the respective variable has been set, and adjust the movement accordingly. If the character has flipped, then we will have to flip it as well. Let's run the game, and now we should be able to move left and right when on the ladder. Yes, it is working. Let's replicate now the changes for the up and down direction, by using the up and down variables. In this case, we don't need to flip the sprite, and we have only to take into account that the vertical speed is given by the ladder speed. Before running the game, we need to go to the handle input function and add the up and down variables to the list of input checks. We will not define new keys for this example, and we will be using the ones that are already defined by Godot by default, UI up and UI down. Let's run the game to see if it is working. And nope. It is not working. It is like blocked. Let's check what could be the problem. Okay. On the change state, when validating if we can change states to the ladder, we need to make sure that it will only change the state if the key up or down is pressed. We don't want to get immediately on a ladder and just go over it. Let's also the possibility to leave the on ladder state. So if we are no longer on the ladder, let's go to the idle state. Let's run the game now. And everything is working fine. We can go up and down. We move off the ladder and the gravity starts pulling again the player as it should be. We can also move on and off the platform while riding it. Everything seems to be working great, and we have 2 new elements that we can add to our toolbox of systems that we can use to implement more complex levels. Before wrapping up this video, let's do something very important right at the beginning of the game: house cleaning. Until now, we have been saving the scripts on the root of the project folder, and the graphics under their subfolders. Let's create a scripts folder and move on to it all the scripts. Let's create now a scenes folder and move all the scenes into it. Supposedly Godot should have kept all the references correctly and everything should be running, except for the manual references that we have across some of the files. Therefore, it is always important to set up the structure of the project at the beginning of the project with none or few files. If you don't do that, then correcting these types of problems will be much more heavy work than just changing a couple of references as we are doing. Let's run the game. and everything is running correctly. In the next episode, we will be looking into spawn points and how you can use them to launch hordes of enemies against the player. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.